So, here's your homework, right? Everybody got a copy down who wanted it? Yeah? No? Maybe? Alright, number 4. What does number 4 say? Please. Y less than or equal to a negative 5x? 2 points. Negative 2, 1. Alright. And what do they actually want you to do? Determine if what? They want you to determine if the point is a solution. How do we determine if a point is a solution to an equation? Plug it in, and do we want something that's true or something that's false? True. So, what's the y coordinate for the first point? 2, negative 5 times my x, which is 3, right? And this is what I want to know. Alright, so what I do is I get just down to 2 numbers, and then I run the test. What's negative 5 times 3? Okay, so now I just have 2 numbers. I want to know, is this statement true? Is 2 less than or equal to negative 15? Is 2, just listen, is 2 less than or equal to negative 15? No. So I mark it no, and I put a slash through the sign. Alright, you have to make sure that you're reading inequality signs properly. So those of you that still read it as like the alligator or the Pac-Man, you need to know which Pac-Man symbol means less than and which one means greater than. Everybody okay? So however you sort that out in your head, I really don't care. Yes. Well, it's supposed to. So if you looked up here, is he eating the bigger number? So it's false. Okay, but you have to make sure that you're good with the language. So if I explain something as a less than or greater than, you need to know which way it's pointing in order for that to happen. Okay? And how I do it is we read everything from left to right because we're English. So if you look on the left side of the symbol, right, is that the smaller end or the bigger end? On the left side. Smaller or bigger? That's smaller, right? That means less than. Small end means less than. If the left edge, if the inequality symbol is written as greater than, right, the left side of the symbol is at the big end or the small end. Bigger end, that means greater. Everybody okay with that? Yeah, but that's also why I run into the issues with you guys who call pound signs hashtags. They're not hashtags. They're pound signs. This means pound. The button on your phone is called the pound button. It's not called the hashtag button. All right, so again, we plug in our x and y, get down to single values. Everybody okay with that? Okay, is 1 less than or equal to 10? So this is true, so we put a yes, and we circle it. Everybody all raw. Any questions on number 4? All right, moving on. Number 10, somebody read it for me, please, and thank you. Whoa, low, low. Yeah, somebody. Okay, and directions say to do what? Alright, so when we graph inequalities, we start them off just like equalities, which means that we're going to isolate which variable? The y. So how do I get y by itself here? Divide by negative 2. Okay, why do I have to flip this on? Right, so whenever you multiply or divide by a negative, flip the inequality, right? So what do I get as an answer down here? Y greater than or equal to negative 4. Okay, what kind of a line is that? When we have just one variable and the one variable is y. Now, is it vertical, horizontal, or skew? Horizontal, right? Okay, so I know I've got a horizontal line through negative 4. Now, this is where inequalities are different, right? Before we just go and graph, we have to figure out if it's going to be a solid line or a dashed line and where we're shading. So if it's greater than or equal to, is that a solid line or a dashed line? Solid because it has the or equal to piece, correct? Okay, and this is saying that we want where y is bigger. Where is y bigger, above or below? Above. So we're going to have a solid line, and we're shading above. So if you give me a minute to get set up. Okay, so you said it's going to be a horizontal line at negative 4, so I go down to 4 on my x-axis, or sorry, go down to 4 on my y-axis, and I put in a solid line. Everybody okay with that? Yes, no, maybe? for this one, yeah, it's saying we want to know where is y bigger. So if I'm here, where are the bigger y's? Above it or below it? Above. So I shade above. Then you would shade where the y's are smaller. So where is y smaller? Okay, then you'd shade below the graph. Okay. If it was less than for this one, we would shade under here. All right, everybody good with graphing a horizontal line? Yes or no? Okay, moving on. Number 20. Okay. So again, when we graph inequalities, we start off as if we would graph an equality, which means that we want to isolate y. Is my y isolated? Yes. So I really don't have a lot of work to do here, but I am still going to find my m and my b. So somebody tell me, please, what is my m? -3/1, and what is my b? -2. Is everybody okay with point-slope form, or sorry, slope-intercept form? Yes or no? Okay. Is the line going to be solid or dashed? Solid. And where are we shading, above or below? Above, because we want the bigger values. Everybody okay with that? Yes. Oh, okay. So, compare what they did to what you should do, right? So I'm going to graph the picture, and then you're going to tell me what they did that's wrong. Okay, so if I were to graph this, right, where do I start, M or B? B, so I go down to 2, right? Okay, from my B, I use my M. What does my M say to do? Do I rise or fall? Okay, I fall 3, and then which way do I go over, left or right? To the right. And then you said solid line? Okay, and where do I shade? What do I want? Do I want where y is bigger or where y is smaller? Bigger. So where are the y's bigger? Above the line or below the line? Above. So I shade above. So compare this to the picture in your book for number 20. What is different between my graph and the graph in the book? Okay, where did they shade? They shaded underneath, right? So that would be a less than. So what would be wrong? They needed to shade the other region. They needed to shade above the line. Number 22. What does that read, please? That's it? Nothing outside? Okay. For absolute value functions, who remembers what's the first thing we need to find when it comes to absolute value functions? H and K. So we're going to need H, we're going to need K, and what do we use those for? To find the what? The vertex. And then we make an XY chart. And again, what goes right in the middle of the XY chart? Your vertex. Okay? So make sure that you know how to do this on your own. For those of you that are just sitting there, I hope this is getting processed. So what do we know about H? The sign always what? Flips. So what's my H value here? +1. All right, a -1 inside becomes a +1 outside. Everybody okay? What's my K? 0. So my vertex is at 1, 0. So I put 1, 0 in my XY table. I go 2 values above, 2 values below. I take these X values and now I plug them in and find the Y that goes with it. So I plug in 3. What's 3 minus 1? 2. What's the absolute value of 2? 2. Plug in a 2. What's 2 minus 1? 1. Absolute value of 1. Plug in a 0. 0 minus 1. -1. Absolute value of -1. 1 minus 1. Or sorry, that should be a -1. My bad. -1 minus 1. -1 minus 1. -2. Absolute value of -2. 2. Everybody good? Yes? No? Maybe? Yes? Okay, so now I get to plot my points. Right? My x equals 1. I'm at 0. 1, 2, 1, 2. Everybody okay with that? Yes or no? Okay, now again, I have to figure out if these are going to be solid lines or dashed lines. So somebody tell me, is this graph solid or dashed? Dashed. How come? Right, there's no equal bar, right? It's just greater than. Okay. So the next thing that we have to do is figure out where do we graph, right? So do I want the y's that are bigger or the y's that are smaller? Bigger, right? And where are the bigger y's? Are they contained inside the graph or are they outside the graph? Inside. So I need to shade inside the graph. Everybody okay with that? Yes or no? So when it comes to absolute value, you're either shading between the two lines, right? You're either shading in the V or you're shading in everything else. So this is saying that I want where y is bigger than the absolute value, right? So where are the bigger y's? Are the bigger y values contained inside the function or outside the function? So like these are my negative y's, right? That's -1, -2, -3. This is 1, 2, 3, right? Where are the bigger y's? Inside or outside? Okay. Do you want me to show you another method for this and see which one makes the most sense? Okay. Okay. Yeah, that's no big deal. All right. So I'll show you all the traditional way of doing this and see if it makes more sense. So what we can do is we can actually use what's called a test statistic. So we're going to take a value, we're going to take a point off our graph and run it through and see if it is a solution to the equation, okay? Because we have to either be here or we have to be here, the region that contains the test value will tell us which piece we're going to shade. So the number that we almost always use is 0, 0 because it makes the math super easy, right? So I want to know, is 0, 0 a solution to the equation? Well, how do you determine if an ordered pair is a solution to the equation? Plug it in, right? This is exactly what we did for number 4. So we're going to get 0 greater than absolute value 0 minus 1. This is what I want to know, right? What's 0 minus 1? -1. What's the absolute value of -1? 1. Is this true? Is 0 bigger than 1? No. So what that means is that 0, 0 cannot fit in the solution area, right? So that means that if I'm shading, I cannot shade in the region that contains 0, 0. And where is 0, 0? Is it outside the graph or inside the graph? It's outside. So this outside region is not my solution. So what piece do I have to shade? Inside. So you can do it that way too with the test value. Okay? This is how you should have seen it last year. Now, the reason why I'm showing you the other method is when we get into chapter 3, we're going to be graphing 3 of these at a time. And you're going to have to shade them all with overlap shades. Okay? So instead of running a test value on every single one, if you can get to where you start seeing the pattern, it can speed up your shading problems. Okay? But if you look at this and go, yeah, I don't know what he's saying, then use the test value. Okay? Everybody right with that? Yes, ma'am. That would be your K value. So, hang on a sec, and I'll show you. Uh-oh. I went back too far. So, yeah, you can use either method. 30. What does number 30 say? Hang on. All right, so 4.5y, right? Oh, plus y. My apologies. Yep, and what are the 2 points? What was that? 3.8 and 0. All right, so this is exactly what they asked you to do on number 4. The only thing that's different now is there's decimals. Oh my gosh, decimals. If only you guys had a handheld electronic device that would make decimals super easy. Oh wait, you do. So use them. What's up, Mr. Long? Yeah, believe it or not, they actually have calculators. All right, so plug in for the first value, right? Plug in what you know. Everybody okay with that? Yes, no? All right. Wow, what's 4.5 plus 1? 5.5, thank you. Less than, what's 1.6 times 0.5? 0.8, right? Everybody okay with that, yeah? All right. So, is this true? Is 5.5 less than 0.8? Okay, moving on to the next question. 4.5 plus 0 less than 1.6 times 3.8. Again, what's 4.5 plus nothing? 4.5. Less than, what's 1.6 times 3.8? 6.08. Is this true? Is 4.5 less than 6.08? Ta-da! Okay, so it's just like the very first section, It's just that now there's decimals and fractions. So use your calculator, and we're running the exact same test. Okay, it's just that the numbers are a little bit different looking. All right, and most of you guys see a big statement and go, ah, and scare yourself so much that you don't even remember what you're doing. All right.